So you've probably heard the term Kubernetes, or maybe K8s, thrown around and wondered, what is that all about? It's like one of the most powerful tools in modern software, but let's be honest, it can also be a little intimidating. Okay, so in this explainer, we're going to dive right in and break down exactly what it is, how it works, and maybe most importantly, whether it's the right tool for you. So here's our game plan. First up, we'll cover the absolute basics, what Kubernetes actually is. Then we're going to pop the hood and look at the anatomy of a cluster, breaking it down into its two key parts, the brains, which is the control plane, and the brawn, the worker nodes. And then we'll wrap it all up by figuring out if this super powerful tool is actually something you need.
All right, let's start at the very beginning. Let's forget all the jargon for just a second. What problem was Kubernetes even created to solve in the first place?
Okay, so at its heart, Kubernetes is a system for managing applications that are packaged up in these things called containers. Now, if you think of your app as a complete meal, a container is kind of like a bento box. It holds everything that meal needs to run, the main course, the side dish, the utensils, all of it, bundled together. Kubernetes, then, is the master chef and the kitchen manager. It's telling all these bento boxes where to go, making more of them if a dinner rush hits, and instantly replacing any that get dropped. It basically automates the entire restaurant. And you know, Kubernetes has this really fascinating origin story. It wasn't just built from scratch in some garage. Nope, it's the direct descendant of an internal system at Google called Borg. For years, Google used Borg to run thousands and thousands of applications across its massive data centers. Then, in 2014, they decided to open source all the lessons they learned from that incredibly powerful tech, and boom, Kubernetes was born.
And hey, here's a quick bit of trivia for you. You'll see Kubernetes shortened to K8s all the time. It's just a nerdy but super efficient shortcut called a numeronym. You take the first letter, K, the last letter, S, and then you just count the 8 letters that are in between. It's the exact same logic that gives us I18N for internationalization.
All right, so now that we've got a handle on what it is, let's see how it's actually built. You know, the easiest way to wrap your head around a Kubernetes cluster is to think of it as having two really distinct parts. You've got the brains of the operation, and then you've got the brawn that does all the heavy lifting.
So these two parts are the control plane, which makes all the big decisions and manages the whole state of the cluster, and the worker nodes, which are the actual machines that run your applications. Simple, right? The control plane gives the orders, and the worker nodes get it done.
But hold on, before we dive deeper into the brains and the brawn, we've got to talk about the one thing they both really care about, the pod. A pod is the smallest, most fundamental building block in Kubernetes. Just think of it as the basic work order. It's basically a wrapper around one or more of your application containers, and literally everything the control plane manages and everything the worker nodes run, it all comes down to these pods.
Okay, let's peel back that first layer and take a closer look at the brains of the operation, the control plane. This is where all the magic, all the coordination really happens.
Now, the control plane isn't just one single thing. It's more like a team of 4 critical components all working together. You've got the API server, a special database called etcd, the scheduler, and the controller manager. Let's quickly look at what each member of this A team actually does.
First up is the API server. This is basically the front door, the receptionist, and the security guard for the entire cluster. Anytime you or any other part of the system wants to do anything, like create a pod, check on its status, or change a setting, you have to go through the API server. It validates and processes every single request, making sure everything is totally legit.
Next, we've got etcd. This is the cluster's permanent memory. Think of it as the official record book, the one single source of truth. It's a super reliable database where Kubernetes stores the complete state of the cluster. Every configuration, every pod status, absolutely everything. If the whole cluster loses power, etcd is what lets it reboot and know exactly where it left off. It's pretty crucial.
Then there's the scheduler. Its job sounds simple, but it's critical. When a new pod needs to get up and running, the scheduler is the one that decides which worker node is going to run it. It's like a logistics manager, looking at what the pod needs, say a certain amount of CPU or memory, and then finding a worker node that has enough free space to handle the job.
And finally, the controller manager. This component is kind of like a thermostat for the cluster. It's constantly watching the system and working to make sure the current state matches the desired state that you've told it to maintain. So if you say, hey, I want 3 copies of my app running and one of them crashes, the controller manager is the one that notices and immediately starts a new one to get back to 3.
So we've met the brains. Now let's go check out the brawn. The worker nodes are where your applications actually live and breathe. This is where the real work gets done. So what turns a regular old serve into a worker node? Well, it's really 3 essential pieces of software that run on each and every one of them, allowing them to take orders from the control plane. These are the kubelet, a container runtime, and the kube proxy.
The kubelet is the control plane's loyal agent on each worker node. It's constantly checking in with the API server, asking, any new instructions for me? Its entire job is to make sure that the pods and containers it's been assigned are actually running and are healthy. It's basically the on-site manager for each individual machine.
So if the kubelet is the manager, the container runtime is the actual engine that's doing the physical work. This is the software. You might have heard of Docker or Containerd that handles all the low-level tasks. It pulls the right application image from a library, starts the container, stops it, and manages its resources, all based on the orders it gets from the kubelet. Last but definitely not least is the kube proxy. This is the networking guru on each node. It acts like a local traffic cop, managing all the network rules that allow your pods to talk to each other and to the outside world. It handles all the routing and even some basic load balancing to make sure requests always get to the right place.
Okay, deep breath. We've covered the what and the how. Now for what might be the most important question of all. Should you actually use Kubernetes? Because, like with most things in technology, it's really all about the trade-offs.
So here is the fundamental trade-off with Kubernetes. On the upside, you get absolutely incredible scalability and reliability. I mean, features like self-healing, where it just automatically replaces a crashed app for you, are built right in. It's also super portable, letting you run your apps the exact same way pretty much anywhere. But the downside is a big one: complexity and cost. It has a notoriously steep learning curve, and the resources you need to run it properly can be pretty substantial.
So let's try a really simple framework to help make this decision. For small organizations or maybe just simple projects, the best advice is often Yagni. You ain't gonna need it. The complexity is almost certainly gonna outweigh the benefits. For massive enterprises with really complex needs, yeah, it's often a perfect fit. And for pretty much everyone in the middle, the real sweet spot is using a managed service from a cloud provider like Amazon's EKS or Google's GKE.
And that brings us to this key piece of advice. Using a managed service means the cloud provider takes care of the hardest part, setting up and maintaining that complex control plane, while you get to just focus on running your apps. It gives you all the power of Kubernetes without all the operational headaches. It's a pretty good deal.
So, we'll leave you with this one final thought to chew on. Kubernetes promises to free you from being locked into one type of infrastructure, right? It gives you this ultimate portability and power. But the question is its own inherent complexity a new kind of trap? It's the central question that every team really has to answer for themselves.